Hello everyone. So today we'll be doing probability, and then you are gonna do Venn diagrams. So as you can see here, I have my Venn diagrams, right? So now, interesting part of probability. So Venn diagrams, they are what you call, Venn diagrams are overlapping circles. So it means what you're gonna be doing dealing with circles like these ones that are gonna be intersecting like this. Maybe there'll be another one coming here. You see, overlapping circles or closed curves within an enclosing rectangle. So it means they will be like this. You'll be given something like this in a rectangle like that. Okay, so they're gonna be representing the items that maybe about the common of groups of items, whatever they have. So we are gonna be using Venn diagrams to help us look and work out the probability of an event occurring. So when you are drawing, you'll be asked to represent a given information using a Venn diagram, or you'll be given a Venn diagram, then you're gonna be asked some questions based on that Venn diagram, right? So, but I want you to know that when you are drawing, we generally use a rectangle. So you're gonna start by drawing your rectangle like this to represent the sample space. So now you're gonna put this is the sample space. The sample space is gonna be like, maybe let's just say you're talking about 100 learners who are doing maths, physics, and life science, whatever. So you're gonna say maybe 100. So these are the people that I'm gonna use, right? And then here, it will be the number of people who didn't participate in that certain whatever. So maybe let's just say 10 learners didn't. Maybe okay. Let me talk about sports, right? We have 100 learners at a certain school. So maybe you'll have maybe rugby here, soccer here, tennis there, right? So you'll have different numbers and people who do two sports or doing everything. So then you'll have 10 learners. So it means in these circles, right, you'll be having a total number of 90 learners who are busy doing that. But Lana, it will be learners who were not participating. So for introduction, this part, it is for soccer and rugby. This one will be soccer and tennis. But this part here, it is the part where learners are doing soccer and tennis and rugby. They're doing all sports. And then I'm gonna show you the Venn diagram soon. Okay, so that's how you represent it. So let's do an example there. So the main thing that I want us to focus on today, it is the representation of a Venn diagram. So let's just say I have something like this now. I have one circle here, which is A. So this S, it is the sample space given, right? So this Venn diagram, this one, it shows event A in sample S, okay? Sample S in Japan. And then let's go to the second one. It is not what I want, Mina. So I'll be having two events. I'll have A there and I'll have B. This will be my sample space. Still fine. So now check. As you can see, the two events are intersecting. So this part here where they are meeting, this is the point of intersection. It is the intersection of A and B. So this Venn diagram, it shows event A and B which have a common value. So they are sharing a common value here. If like maybe they're saying you have 10 in A, okay, maybe in the statement they might say 10 in A, it means maybe you might have 8 here, and then inside here you will have 2. You see, something like that. I'm gonna show you the Venn diagram soon. But the main thing that I want you to know is that this point here, it is the intersection. This is the probability of A intersecting B. You see, A and B. So this is the part where they overlap. It is called the intersection. So the section that is shaded, it belongs to the event of A and B, since I have shaded it, right? Okay, now let's go to the main thing. I want to show you A, B, and C, right? They are intersecting here. I hope you are getting that one. So let me show you the last one by the Anita I told about mutual exclusive events last time on the previous video. So you'll have your A here and your B here. As you can see, they are not intersecting. So this Venn diagram, it shows event A and B which have no values. There is no value here. So A and B are called what? Mutually exclusive events. Or sometimes they can call it disjoint events. But no, don't take that one. Just say mutually exclusive events. Yeah, because they are not intersecting. The probability of A and B is equals to 0. So now let's go to the main thing for today. Now this diagram is the Venn diagram for event A, B, and C. So Lana, you'll have A here, B here, and C. But before I continue, I want you to know that this is A only. This is very important. A only. And then this is B only. And then this is C only. You're going to understand it when you're going to be doing examples. I'm going to do a past paper for you separately, because I don't want you to confuse yourself, because you're just getting to know the topic. So it is A only there. Okay, so since you have A only, it means there are certain people who are doing maybe a sport, one sport only. Okay, only, it is very important. And then Lana, this is the intersection of what? Of A and B. It means this is what? A intersecting B, or A and B. Now let's go to the intersection of A and C. This is what? A and C. This is the intersection of what? A and C. And then the intersection of B and C is going to be what? B intersecting C. Now what about this part? As you can see, this, it is coming, it is visible there. The one for C, it is also visible there. And the one for A, it is visible there. So what does it mean? Let's talk about sports. It means people are loving soccer. Like, there are learners who love soccer, and there are learners who love tennis, and there are learners who like rugby. You see, so this is A intersecting B intersecting C. You're gonna see it in examples whereby someone do more than 2 sports. He or she can do tennis, rugby, and soccer there. You see, but the main thing it is to know that this is what? A only. And another thing that I want you to know is that this thing as a whole, it represents what? A, right? But I want you to know something. They can tell you that maybe 50 people are interested in, let me say, soccer. So let me say you're gonna have soccer here, right? But they're gonna leave it like that. Then they will say 23 people like soccer only. Then you know what you have got, 23 here. But at the same time, they will say 23 people, maybe like 10 people, maybe 10 people like soccer and what? Rugby. So you know what Lana have what? 10. But remember, this thing, must be equals to 50. You see, the 50 is not going to come here, but it must be the sum of all the numbers that you're going to add in here. So since I already have 33, it means what I'm left with what? 17. So let's try to balance. Then they will tell you that maybe 15 people are interested in all sports. So maybe it will be A, B, and C. So that 15 will come here. So now, since I have 15, Lana, I already have what? 25, 23. What am I left with? And this is just hypothetical example. So I have 48 here, right? So it means only 2 people do what? Soccer, and maybe I rugby here. So when we add 10, 15 plus 10 plus 23 plus 2, I get what? 50, because this is 23, this is 2, 25. 25 plus 25, you see, is 50. So you must know that this thing as a whole, it gives you what? 50, but there are certain numbers for certain spots and stuff. Okay? Yeah, that's how it goes. Sometimes they can even give you x there by the intersection of the three spots. They can say find the value of x. So let me find a juicy example. Yeah, let me check the one that has x there and we'll see what we can do. Okay, let's check. It's a past paper. It's a question from a past paper. So they already drew the Venn diagram for us, but I'm gonna interpret it and tell you how this thing is working. So now the statement is saying Tabo pulled what in 250 people, right? So I already know that my sample date is 250 to determine if they liked shampoo A, B, or C. So these are his results. So as you can see, the people from A, B, C that like shampoo, we don't have a value, it is X. So we have okay. So as I can see there, I have 3 types of shampoos. We have shampoo A, shampoo B, and shampoo C. So now the people that like all the shampoos, we don't have the value there, it is X. But the people who like shampoo A only, it is 33. People who like shampoo A and C, it is 15. People who like shampoo B and C, it is 25. People who like shampoo A and B, it is 40. And then people who like shampoo who like shampoo B only, it is 65. People who like shampoo C only, it is 20. So now, let's check the first question. They are saying how many people like all shampoos? All shampoos. But as I told you that we don't have the value there, so it means we will have to calculate X. But as I'm given the total number of people who participated there, so I'm simply gonna say X, it is equals to 250 minus. So what am I gonna subtract? I'm gonna subtract all the numbers that I can see there, right? So I'm gonna start 65 plus 40 plus 33 plus 15 plus 25 plus 20 plus 22. You see, as you can see, these 22 here are the people who didn't participate, but I'm still gonna add it because they are still part of the sample number, which is 250. Don't forget the 22. Okay, so let's take the calculator. So we are gonna say 250 minus 65 plus 40 plus 33 plus 15 plus 25 plus 20 plus 22. As you can see, I'm getting what? 30. So my X is equals to 30. So 30 people like shampoo A, shampoo B, and C. They like all the shampoos, right? So now let's go to the next question. I'm gonna do a few questions in here. Determine the probability of randomly picking a person that likes shampoo A or B. So now they're saying shampoo A or B. They didn't tell us only, so they just said A or B. Okay, so it means we are gonna do what? Add the total number of A and the total number of what? Of B. So already this is what I have. Okay, so line I have 65, 40, then line I have what? 30 there, and then I have what? 33, 15, 20, 15. Okay, so okay, I don't have the number of people who that. Oh, do I have the number of people who like B and C? Oh, okay, I already indicated there, so everything's fine. I'm gonna represent it later on. Okay, A or B. So probability of A or B, it is gonna be like this. I'm gonna add all the numbers that you see here related to A and B. So it is gonna be, because to remember, favorable outcome over total outcome. So I have over 250 already. I'm gonna say 33 plus 65 plus 40 plus 25 plus 15 plus 30, because you just got the value. Take out your calculator. 33 plus 65 plus 40 plus 15 plus 25 plus 30 over 250. What are you getting there? 104 over 125. Okay, let's check there. Yes, 104 over 125. Then we can take it to decimals. 0, so let me write my answer. 104 over 125. Then if maybe they wanted it decimal, you can write it as 0,832. Then in percentage, 83.2%. You see, that's how you do it. So now let's go to the next question. Determine the probability of randomly picking a person that only likes shampoo A and B. So now you're gonna take what? A and B only. Okay, this only must be inside, sorry. A and B only. So now A and B only, I told you this what? 40. So it means we'll tell 40 over 250. You see? Then you can convert it to decimals on your own in percentage there. That's how we kill this thing. Just have to know how to interpret your diagram there and be able to know which one is this and this, what, and that. You see? So if they say determine the probability of people who didn't like any of the shampoos, you're gonna do it like this. Like, what is the probability of randomly picking a person who doesn't love any of the shampoos? So I told you that the 22 here, it is the people who didn't participate or even check the shampoos. So you're gonna say probability of not A, remember this one I told you, and or not B or not C is gonna be what? 22 over 250. Then we're gonna convert it to the decimals and percentage there on your own, as you can see. It's just simple there. All right, good stuff. Let's check the last one. So determine the probability of randomly picking a person that doesn't like shampoo C or B. So it means you're gonna ignore these ones, but take what? This 33 here and what? The 22 that you can see here, because they said not C, not B. So this what? Not C or not B. It's gonna be what? 33 over 250 plus 22 over 250. You're gonna add and get 33 plus 22 is 55 over 250. Then you take it to decimals on your own. Okay, that's how you kill it. Okay, all right, thanks. I hope you enjoyed. I'm gonna update the past paper for you soon. Thanks.